Today we're going to be talking about some different factors that affect climates of a region, why climates are the way they are based on these different things. We're going to talk about 5 different factors today, which is latitude, and related to that is the amount of sunlight that a place receives. We're going to talk about temperature, humidity, pressure, and clouds. You're going to need your notebook. Obviously, you're going to need a pair of headphones to listen to this video as well. So go ahead and get those ready now. You have a set of questions on Schoology that I'd like you to write down in your notebook or look at while you're watching this video and answer in your notebook in complete sentences. So you want to get that up on your screen as well, either split screen or get those questions written down in your book, as well as the 7 vocab words that you're going to see in this video. First thing we're going to talk about is latitude. We've mentioned latitude before. Those are those invisible lines that wrap around the globe going from east to west. And what latitude measures is the distance away from the equator. So how far you are from the middle of the Earth. The higher degree, the further away you are from the equator and the closer you are to one of the poles, either the north or the south. So the way that we measure that is in degrees. Equator is at 0 degrees, and then both of the poles are at 90 degrees. So the North Pole would be at 90 degrees north, the South Pole is at 90 degrees south. And those invisible lines that wrap around the globe are called parallels. So if you hear somebody mention the 30th parallel north, that means you are 30 degrees north of the equator. Latitude plays a role in climate because where you are on the globe determines how much sunlight you're going to get. And when I say where you are, not so much where you are longitudinally, around the globe, but where you are north or south of the equator. If you're at the equator, that's where the sunlight is going to be most intense. The sun's rays are concentrated in a very small spot at the equator, as you can see on the diagram on your screen, and then as you move either north or south from the equator, those rays get more spread out over a larger distance, and the sunlight is less intense, it's less concentrated on a particular spot. Another thing to consider with latitude is where you are in the world determines your day length as well, depending on the season and the time of year. If you're at the equator, your day stays the same length all year long, but if you're anywhere else, like for example where we are, you're going to have shorter days in the winter and longer days in the summer. And the reason for that has to do with the tilt of the Earth and the position of the Earth around the Sun, as you're going to see in this clip here in a second. The Earth does not sit straight up and down perpendicular to the Sun. It's tilted slightly at about a 23-degree angle. And that tilt of the Earth means that one side of the Earth is going to be pointed towards the Sun, in this case the southern hemisphere, and one side pointed away. And then as you move around the Sun and you orbit, the northern hemisphere is going to get summer and the southern gets winter. So in addition to sunlight, one of our other factors is temperature. Latitude does play a big role in temperature. You definitely find warmer climates near the equator and colder ones as you get towards the poles. But latitude isn't the only factor into what makes temperature of a climate. You've also got to take into account things like prevailing winds. Where are the winds coming from? Where are they blowing to? Altitude is how high above sea level you are. That makes a big difference in your temperature. Generally, if you're at a very high altitude, like up in the mountains, your temperature is going to be lower. If your area is very cloudy, how far you are from an ocean. In your article that you read on Monday, it talked about how coastal areas near water tend to have more mild temperatures. They don't have big swings between hot and cold because that water insulates them in a way. You have to look at ocean currents. Do you have a current near you? Is it a warm current? Is it a cold current? And then one of the other factors that you look at with temperature is called local relief, which mostly involves how much vegetation or how many plants, trees, grasses, bushes do you have nearby. Generally, you see hotter temperatures in places with less vegetation, places like cities and deserts. Um, and you see cooler temperatures in forests. And then grasslands would be sort of in the middle. Temperatures change or fluctuate both throughout the course of a day and over different seasons. Um, the way we measure temperature in the United States with this Fahrenheit scale, so we measure temperature in degrees Fahrenheit. Pretty much the rest of the world uses the Celsius scale, which is measured in degrees Celsius. The difference there being that in Fahrenheit, freezing is at 32 degrees, boiling point is at 212. Celsius is a little bit easier to remember. Freezing is at 0, boiling is at 100. So we mentioned that temperatures vary throughout the course of the day. This is caused by the sun rising and setting. When the sun comes up, you start getting heat and energy from the sun, warming the air around you and warming the ground. Once the sun rises, your temperatures start to increase. If you look at the screen and you look at that graph at the bottom, that's our 10-day forecast in Oxford at the time that I was filming this, and you can see that red line is the daily temperature change, and you can see that it goes up and down and up and down. Sometimes people assume that the hottest part of the day is going to be right at noon, at midday. That's actually not the case. The hottest part of the day is usually a few hours after noon, and that's because you have the sun rising. And as long as the sun is up, the air and the ground are absorbing that heat energy. And you don't just stop absorbing energy at noon. The sun is still up. The air is still absorbing energy. So it's just going to get hotter until the sun sets. And then the temperature will decrease. In addition to changing over the course of the day, temperature also changes with seasons. Again, this goes back to that animation you saw before, which you'll see again in a second. The closer you are to the sun, based on the tilt of the earth, whether you're in the north or in the south, that's going to determine whether you are in summer, which is warmer, or winter, which is colder. So winter, you're pointed away, summer, you're pointed towards the sun. If you're at the equator, you're not going to experience those fluctuations because you're the same distance all the time. Humidity is something that you touched on briefly on Monday. It's a measure of how much water vapor or evaporated water is in the air. As that might imply, humidity increases when water evaporates. So as water warms from the heat of the sun, it starts to evaporate, it forms vapor, that vapor stays in the air, and then as that vapor rises, it condenses into clouds and falls back to Earth. And the reason that humidity decreases when water condenses is because once it condenses, it's going back to liquid water. It's no longer water vapor. So if we're just measuring water vapor, as we're condensing, that means we're getting less vapor. We're getting more liquid water, but less vapor. One thing to mention when we talk about humidity is the heat index. Heat index is a measure of how hot the temperature feels rather than how hot it actually is. And this has to do with the humidity. If the humidity is very low, it might feel cooler than it actually is outside. If the humidity is high, it might feel much warmer than it is outside. So for example, in the Mississippi summer, if you ever look on a weather forecast or a weather app, and it's a very humid day, it might say that it's 90 degrees outside, but it feels like 107 because of the high humidity increasing the heat index. It feels much hotter, even though it's actually not. When I lived in Arizona, people would always tell us that we were lucky because it was a dry heat. And what they were saying there, what that actually means is that the humidity is extremely low in the desert. It usually hovered somewhere between about 2 and 5%. So our heat index was always very low. and that helped when it was very hot, even though may have been 105 degrees. Maybe it only felt like about 100 degrees or 98 degrees, because it was a quote-unquote dry heat. Air pressure is something we've touched on briefly before, but it deserves to be gone into in a little bit more detail. Air pressure is the force of air molecules pushing down because of gravity. So if you think about the air, it's not just nothing. You have all of these different atoms and elements: nitrogen, oxygen, hydrogen, and they all weigh something. Not very much, but they all weigh something. And if you think about how much air is between you and the top of the atmosphere, that's actually quite a lot of air. To put that in perspective, if you took a column of air that was only 1 square inch, but it went from the surface of the earth all the way to the bottom of the atmosphere, that's about 14.7 pounds of air pushing down on just that 1 square inch. When we talk about air pressure, we're generally talking about areas of high and low pressure, and the reason that we get areas of high pressure in some places and areas of low pressure in other places, and it changes over time, is because of uneven heating of the air by the sun. Obviously, the Earth is always rotating, so the sun is not just shining in one single spot. It's heating up some places, it's heating up other places. It's not heating them all equally because of winds and clouds. So it creates different areas of pressure. You might remember from your earlier science classes that warm air rises and cold air sinks. Rising areas of warm air cause low pressure. Areas of cold air sink and they cause areas of high pressure. One thing to keep in mind also is that air pressure changes with elevation. Remember, elevation is your height above sea level. As your elevation rises, as you go up, your air pressure is going to decrease. And the reason for that, if you think back to what I just told you a minute ago, if you imagine all of the air above you between you and the atmosphere, if you are going up, that means there's less distance between you and the atmosphere, which means less air pushing down on you, which means less pressure. We're going to go a little bit more in detail about pressure in terms of weather that it creates. We're going to start with areas of high pressure. Areas of high pressure are also sometimes called anticyclones. So in the northern hemisphere, an increase in pressure, an area of high pressure, will cause air to move in a clockwise direction, and that's in the northern hemisphere. In the southern hemisphere, it would be the opposite. It would be counterclockwise. High pressure, as you've heard before, is generally associated with clear skies and good weather. The reason for that is that anticyclone movement, that movement of the air outwards, pushes the air away and it forms this empty space where the air was. And that empty space naturally wants to be filled with something. So air from higher in the atmosphere will sink down to fill that empty space that's left behind, causing that clear weather and those good weather and clear skies. Opposite from that, we have areas of low pressure, which are called cyclones, and those move in a counterclockwise direction in the northern hemisphere. You can see on the diagram on the screen that the arrows in the area of high pressure are spiraling outwards, and the areas of low pressure have air spiraling inwards. And we've said before that low pressure is generally associated with clouds and rain. And the reason for that is that when you have wind coming in and it meets an area of low pressure, those winds and that air rises and it carries water vapor with it. Whatever water vapor was being carried by that wind rises also. And when that water vapor rises, it starts to condense. And when water vapor condenses, it forms clouds. And eventually, if it condenses enough, those clouds will start dropping rain. Speaking of clouds, just to get a quick definition of a cloud is formed when water vapor condenses in the atmosphere. Clouds can be made of either water or ice. Um, and one of the ways that they influence climate and weather is that they can block some sunlight from reaching the ground. So you might have noticed that it feels a little bit cooler on cloudier days. You're not getting as much sun, you're not getting as much of that heat energy. Um, there are many different types of clouds. The way that we classify them is generally by their shape and then by their height in the atmosphere, what layer of the atmosphere we find them in. And on your screen, you have one example of a type of cloud. This is a cumulonimbus cloud, and these clouds are a sign of an approaching thunderstorm. And they generally are associated with rain or lightning or thunder.